notebooks. We'll just take notes today, and I'll kind of read it out because I know it doesn't look as clear from the board. But in the very first problem, it's very much like the problem like you had on your last quiz. Okay, so, and I didn't count those problems. So we get a little bit of practice, and then we'll move on to the new part of it. So this problem here is basically saying you're multiplying each term at the top by 9x to the second. So if you really wanted to, you could actually do this. And actually divide each number by 9x to the second. Okay, so we're just going to divide. 9 divided by 9, that's one whole. And then when we subtract our exponents, because that is the rule for exponents, you get x to the third. Okay, 27 divided by 9 is 3. When we subtract the exponents, we get x to the second. And 27 divided by 9 is 3 again. And when we subtract the exponents, we get 1. Now, and of course, like on your quiz, you know, some of them came out to be negative when you subtract. So what if I had 2 minus 3 instead of 3 minus 2? Then that just simply means that we would have dropped the variable in the denominator. Okay, so we know how to work with negative exponents. You take the reciprocal of them, so it would have just ended up in the denominator instead of at the top. That's it. All right, let's take a look at number 2. So again, if you want to put the 6x under each term, so this says x to the 5th divided by 6x, 18x to the 4th divided by 6x, and 18x to the 3rd divided by 6x. So each term is being divided by 6x. Now, you know, like on your quiz, the division was over here, but it means the exact same thing. Okay, and then you could also see it written this way. Okay, that's also division, and they could have put everything in the numerator under the square root. Okay, so, well, not square root, I should not have said that. It's not a square root, but they could have just put everything right here under the house, right? So now when we actually divide, we're only subtracting the exponents because we're not reducing the 6 with anything. So the 6 will stay where it is. And when we subtract these, we get 5 minus 1, which is 4. Okay, then 18 divided by 6 is what? 3. Subtract, you get x to the 3rd. 18 divided by 6 is 3. Subtract your exponents, you get x to the 2nd. Okay. All right, so let's move on to what if we have a binomial at the top. So basically what has happened here is these have already been factored for you. So in a few minutes, you're going to see some ones that have not been factored. So these have already been factored. So we have 2x plus 1 times x minus 3 divided by x minus 3. Okay, so what's going to happen here is you're going to be crossing out like factors. For instance, x minus 3 at the top, x minus 3 at the bottom. That really is one whole, okay, technically. But you don't have to write the 1. So you're just left with 2x plus 1. And you can drop the parentheses when there's just one thing left. When there's just one binomial left or one expression left, you don't need to keep the parentheses. Okay. Like here, we're dividing each term again. So you're just crossing out like factors. So we're going to cross out the 3x plus 1, 3x plus 1. I'm left with 2x minus 6. It's that simple. Crossing out like pairs. Okay. I want to point something out on this one. You could also factor out a 2. So I would probably go even further and say x minus 3. Okay, because technically that's not factored completely, because there's a common factor here too. All right, let's move on to this one. Now, this particular example It has not been factored at the top. So we need to take this x squared plus 5x minus 14 and write it as a binomial times a binomial. Okay? So the question is, what times what will give you negative 14, but it adds up to a positive 5? I know 7 and 2, I can get a positive 5 some kind of way. So what would that be? 7 and 2. Plus 7 minus 2. Okay, that gives me negative 14, and it'll add up to my middle number, positive 5. Okay, what can I cross out? I can cross out the x minus 2's, and then I'm left with x plus 7. That's it. So like I said, if you know how to factor, this lesson is very easy because all you're doing is factoring and crossing out like pairs. Okay, let's look at number 6. Factor the top. So what times what will give you a positive 15, but will add up to a negative 8? Okay, a minus 3 and a minus 5. Okay, we cross out the minus 3's and we're left with x minus 5. Okay, again, it's just all factoring and crossing out like pairs. And you can only cross out one pair at a time. Okay, so like if there had been another x minus 2 at the top, I can't cross it out again unless I had another x minus 2 at the bottom. All right, let's take a look at this. Now we have to factor the numerator and denominator. Okay, not a problem because we know how to factor. So we're looking for factors of negative 28 that will add up to positive 3, right? So if we got 7, and that's a positive 7 and a negative 4. Okay, so that's for the top. So what times what will give us 35 that equals a 12? Okay, let's tell me. 7 and 5, very good. And then x and x. And then we cross out again the pairs that are the same, the x plus 7's. So I'm going to be left with x minus 4 over x minus plus 5. So again, crossing out like pairs. You can only cross out one pair at a time. All right, let's do number 8. What times what will give me negative 24, but will add up to negative 2? Okay, 6 and 4, which one needs to be negative? Which one needs to be positive? Negative 6, positive 4. All right, let's do the bottom. What times what will give me negative 18, but will add up to negative 3? Okay, negative 6 and positive what? Positive 3. Very good. So then I cross these out, and I'm left with x plus 4 over x plus 3. Now, all right, so now I want you to go to page 24, and you still probably need to have out your spirals, okay? So don't put those away just yet. All right, so page 24. Okay, I'm going to write down the first problem, and you can write it down as well. So this says 12m squared n to the 5th, and then m plus 5 divided by. All right, so these are a little bit more challenging. Okay, so you got, the process of what you're supposed to do. So now let's kind of step it up a little bit. Now, division this way, just as if you had fractions without the variables, you actually have to multiply by the reciprocal. Okay, how many people know how to divide with fractions? Like if I had 1/2 divided by 3/5, wouldn't I have to do 1/2 times 5/3? So you're going to have to do the same thing. Just because they're algebraic fractions, you still got to flip that second fraction. Okay, just as if, because it is still a fraction. It just has variables in it. So we're going to rewrite the same problem, but we're going to change it to multiplication. and reverse the numerator and denominator, because that's how you divide with fractions. Okay. Okay, so everything actually has been in simplest form except for this. We need to factor this m squared minus 25. So how do we do that? Is that a special case or not? Is m squared minus 25 a special? Yeah. Yes, it is. All right, so we just take the square root and say m plus 5 and m minus 5. So you got to recognize the special cases. Okay. All right, so this is what I'm left with after I just take the m squared minus 25 and I actually factor it out. Can I cross out any like pairs? Yes. M plus 5, m plus 5. So what am I left with at the top? Now, I'm really not done because I want you to pay close attention. I can also cross out these numbers here, this 12 and this 3. What can go into 12 and 3? 3. So 3 will go into 12 how many times? How many? 4. And 3 will go into itself once. So this is where you're just, simplifying as much as you possibly can. Can I take care of the m squared and the m to the third? Yes, I can. Okay. I can actually reduce these as well. Okay, what is my process for dividing with exponents? Do I add or do I subtract? You subtract. So first, let's just go ahead and kind of take this all and write it as our next step before we do that. So it'll all be together. So I'm just writing down everything I have not crossed out. Okay. So that kind of, makes it a little bit easier for us to subtract the m's and subtract the n's. All right, so now I'm going to keep the 4 where it is. I'm going to take care of these. And I'm going to say 2 minus 3 is -1, so it needs to go in the bottom. Okay, then I'm going to subtract my n's. 5 minus 1 will give me 4. And then I'm going to just write down the other part of that, which was the binomial. So if you look off to the side, you should see that answer, and you should see the letter U beside it. So for question number 1 at the bottom, you'll go down at the bottom for question number 1, and you're going to write the letter U. Okay. All right, so let's keep working. We're going to do number 2. N squared minus 9n plus 20. And I'm going to go ahead and flip it now instead of writing the problem and then flip it. So now I'm going to change it to multiplication. I'm going to put the 10mn squared at the top and the 5n minus 20 at the bottom. Okay, so I got to factor this trinomial at the top. N squared minus 9n plus 20. What times what gives us 20? That can add up to -9. Is that -5 and -4? Okay. And I'm just going to leave this 10mn squared. I'll take care of that in a second. Okay, let's just do one step at a time. I could also factor this. What is the GCF in here? What do these two numbers have in common? 5. So I'm going to factor out a 5. Okay. So I'm going to cross out these n minus 4. And I'm going to also reduce the 10 and the 6. What can go into 10 and 6? 2. 6 divided by 2 is 3. 10 divided by 2 is what? 5. Okay, so let's make that a 5. So now I'm just going to go ahead and write what's left at the top so I can simplify it with these variables at the bottom. So I'm left with the 5 at the top. And look, I know eventually I'm going to cross these out, but right now let's just write 5 at the top, n minus 5. Okay, so I wrote that. At the bottom, I'm going to be left with this 3 times 5 times the, actually, let me write it a different way. I'll just say 15. I'll just go ahead and multiply the bottom together. So I'm just going to take these and multiply them together. So 15, and then I forgot to write this. And then I'm going to have m to the 7th and to the 2nd. Is that right? So this is what I had left at the top. I had the 5 left at the top. I had the n minus 5. I had the m n squared. All of that was left at the top. At the bottom, I went on and I multiplied this 3 and 5, and I got 15. And I brought down the m to the 7th and n to the 3rd. Now, can I reduce 5 over 15? Absolutely. Okay, what is 5 over 15? 1/3? Okay, so I'm just going to change this to 3 at the bottom. I really don't need to write that 1 there. That's invisible. Okay, so that reduced to 1/3. So that's taken care of. All right, so I'm going to have the n minus 5 still. Okay, but I need to go ahead and say what these m's are. What is 1 minus 7? -6. Let's put that at the bottom. And these will cancel out. Is that correct? And then I'm just left with the n minus 5 at the top. Okay, so if you go down to the very bottom, you'll see letter E. It says n minus 5 over 3m to the 6. Okay. All right, I'm going to do one more with you. Okay. So you would then only have 6 more to do. Okay, so I'm doing the first 3 with you. So m squared over m squared minus 7m. I'm going to go ahead and change it to multiplication and put the m squared minus 4m minus 21 at the top, divided by 1. Okay. All right, so we need to factor that m squared minus 4m minus 21. How can we factor that? All right, so m minus 7 and m plus 3. Can I factor out an m here at the bottom? Don't they have m's in common right here? So I'm going to take out an m, and that'll be m minus 7. All right? So I can cross out the m minus 7's. And at the top, I will be left with m squared times m plus 3. And at the bottom, I'm going to be just left with m. Now I am going to subtract these m's. What is 2 minus 1? M. All right, let's see if we see that answer. It should be letter T. It's at the top, the third one at the top, letter T. All right, so you'll finish up the rest. So sometimes if you cannot factor it like this, as a binomial times a binomial, you can pull out the greatest common factor. Okay, so it kind of really takes everything that we've learned from this unit and put it all together.